Okay, 3.1, functions being even or odd. Um, hey guys, up here. So we will say that a function is even if it is symmetrical about the y-axis. Okay, so that's what it means for a function to be even. It is symmetrical about the y-axis. Which axis is this right here? This is x. This is y. If it's symmetrical about the y-axis, what does that mean in your words? What does it mean to be symmetrical about the y-axis? Right, the same on both sides. Or the two sides are what images of each other? Mirror images of each other. Okay, so you can tell by looking at this graph, it's at the origin, it goes up, down, up. And then on the left side, it goes up, down, up. It does the same thing on both sides. This is what an even function would look like. So I can look at the graph of this and say that function is even because it is symmetric about the y-axis. So that's what an even function would look like. Now, what you will probably see on test is something like this. I give you part of a function and say, I would like for you to make that an even function. So what is this? This is calling your artistic skills into play. What do you need to do to make this an even function? You just need to figure out, okay, what is it doing over here? It looks like 1, 2, just past 2, it goes up to 2. So somewhere here, it hits about right here. And then at -2, it hits the axis. So this function needs to do something like this to be an even function. So that would make this an even function if it looks like the same on both sides, or it looks like a mirror image or a reflection. Okay, this one's a little bit more complicated, but you can handle it. To make this an even function, okay, if I want to make this one an even function, I need to make it look the same on both sides. Okay, so here's the y-axis. What's the reflection of this point? Where is that point? If I reflect it, where will it be? Same spot, okay? Now, you look at this point, here's the y-axis. I had to go to the left 2 to get to this point. Its reflection we found by going where? To the right 2, okay? So if I put a dot right there, if I connect these dots, that makes that part even, okay? Now, if I look down here, there's an open circle. 1, 2, open circle. Where will I put the reflection? 1, 2, open circle here, okay? And then this one is, if I go down to 2 and 1, 2, 3, 4, left 4, so here I will go down 2 and go to the right 4. 1, 2, 3, 4, put a closed circle and connect those dots, okay? That makes this an even function, okay? So it's an even function because it is a reflection on both sides. Now, let's look at these functions. Can you tell me if these functions are even or not? So let's look at this. The first function here, is this an even function? Yeah, I can look at that and tell you that that is an even function because it is the exact image on both sides of the y-axis. What about this function? Is this even? No, this is not an even function. Because what it does here, it goes up and then down. It would have to go up and down, but here it's doing the opposite of that. Okay. What about this function here? Is this an even function? No, this function right here is not even. What about this one? No, this is not even because if you look at where the y-axis is, it would need to be perfectly symmetrical about that line. It's not. What about the one here? Yeah, this one is even. If you draw a line where the y-axis is, I see the same thing on both sides of that axis. Okay? So that's what an even function looks like graphically. Let's look for example real quick. If a function is even, so wherever this point is, let's just pick a point right here, okay, on this graph. So if I substitute a 1, I'm going to get this as my y value. Okay, if it's even, What will I substitute over here to get the same value? Yeah, a -1. Okay, so a -1 will give me the same value. So f of 1 and f of -1 give me what? The same thing. That's what it means to be a reflection. So wherever you are on the axis, so if I go back over here to this one, f of 2 is right here. F of -2 matches it. So the y values are the same. So another way to think about an even function, even means the same. You get the same numbers on both sides of the y-axis for your graph. So what you should be able to do, you should be able to look at a graph and tell whether that graph is even or not. We've got another figuring out how it's odd that we'll hit next. But if it's symmetric about the y-axis, it's an even function. The other thing that you will know algebraically, and we'll spend more time on this tomorrow, if it's an even function, f of x and f of minus x are going to be the same. Like if you plug in a 2 on this side of the equation and you plug in a -2 on this side of the equation, you better get the same things if it's an even function. That's what makes it a mirror image. Okay, so you guys, I think there are 1 or 2 examples here. One example. You guys work on the next one. So take this function and complete it to make it an even graph. And I will just work on that right here. Okay, you should get something that looks like a W here. What is f of 3? So when x is 3, what value do I get? What do I get for f of 3? 1, 2, 3. What is f of 3? 0. Okay. This is your x value. Okay. When you plug in a 3, you're going to get a 0. So what should f of -3 be? Should also be 0 if this is an even function. So here's -3, and here's 3. What is f of 7? When you plug in a 7, what do you get? F of 7 is 4. So I should expect f of -7 to be what? 4. If it's an even function, f of 7 and f of -7 have to be the same thing in order to get this reflection. Okay. Now let's take a look at a graph. We'll spend more time with this graph later, but let's graph f of x equal x squared. So if I plug in a 0, what is 0 squared? 0. -1 squared. 1. 1 squared. 1. -2 squared. 4. And 2 squared. 4. Okay. So I see here that f of -1 and f of 1 are the same. F of -2 and f of 2 are the same. This should be an even function. So let's plot these points. 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And I should see something that looks like this. Is that an even function? Yeah, pretend that I drew it and it was exact mirror images of each other. What you're seeing graphically, you're seeing whatever point I have over here, I have a corresponding point here. That's what it means to be a mirror image. But algebraically, what you're seeing is f of -1 and f of 1 give you the same thing. F of -2 and f of 2 give you the same value. So is this an even function? Yes, this is an even function. So graphically, I'm looking for those mirror images. Algebraically, I'm looking for f of x and f of -x give me the same value. Yes, question? So is x squared like 1? Yeah, so you're in this notation, this f of x, this just means your y value. Okay? So x is your input. I input x, y is my, if x is the input, y is the output, okay? Another way, you're going to see this notation. Instead of writing y, I'm just going to write f of x, okay? So you plug in the x, and you get f of x, or a y value, back from that. So the y value is x squared in this case. Now let's talk about a function being odd. So even means it gets the same value as symmetrical about the y-axis. We will say that a function is odd if it is symmetric about the origin. The origin is the point 0, 0. So if it's symmetric about the origin, what it does on one side of the origin, it does a complementary thing on the other side of the origin. So the way I think about odd, I think of odd as opposite. I think of even means the same. I think of odd means opposite. So to be symmetric about the origin, so here's the origin. So if it's symmetric about this, here it goes up and then it goes down. To make it symmetric about the origin, this one goes down and then up. Okay. So what it's doing on both sides of the origin is symmetrical. Okay. Now, the easier way I think of it is whatever it's doing on the left side, it does the opposite on the right. So it goes up a little bit and then down to negative infinity. So the opposite of that would be going down and then up. So this is what an odd function would look like. It does the opposite thing on both sides of the axis. So let's look at the next graph. To make this an odd function, okay, so to make this an odd function, so I see it comes down here and it sort of levels off. What would be the opposite of doing that? It would do something like this and then it would go down this way. That would be what the opposite of that is. So this would make this an odd function. Let's look at the next example. Now, odd means the very opposite thing, okay? So, in this case, it looks like here, I go, to the right 6, okay? What's the opposite of going to the right 6? To the left 6. So I'm going to put a dot right here, okay? Now, describe how I get from the origin, how do I get to this point right here? What do I do? How do I get from origin to here? What directions do I take? I go to the right, what? 2. This point right here. 4. I go to the right 4 and what? Up what? 6. What's the opposite of going to the right 4 and up 6? Left 4 and down 6. So that's this point right here. Okay. How do I get from here to this point? You go up what? Up 6. What's the opposite of going up 6? Down 6. Okay. So that's right here. So this is, that's what makes this an odd function. Okay. So all I did was, whatever was done on the right side of the equation, I did the opposite thing here on the left side of the equation. So that's what makes this an odd function. And so the way I do that, I look at every point. I got 3 points here. And so if this point is found by going upward 6, this one is found by going down 6. This is found by going to the right 4 and up 6. This is found by going to the left, did I do it wrong? Left 4 and down 6. So it should be, let me draw that a little bit better. So it should be left 4 and down 6 is right here, and then right here, and right here. Okay, a little bit better. Now, what if the instructions were to make this an even function? What would that look like? If the original problem was to make this even, what would I do? Yeah. So this is to the right, so I would still get this point. But for this point, 1, 2, 3, 4, I would go 1, 2, 3, 4. I would do this, okay? So this is what, the green is what makes this. So I could ask you on a test, make this an even function or make this an odd function. Does everyone see the difference between the two? Okay, even is just mirror image about the y-axis. Odd means you're doing the very opposite thing on both sides of the axis. Now, you should be able to look at a graph and tell that if it's symmetric about the origin, that's what makes it an odd function. I rather than think symmetric about the origin, I like to think of it does the opposite thing. So if what I see on the right side of the axis and what I see on the left side of the y-axis, if those things are the same, it's even. If those things are opposites, it's an odd function. Okay. So if it's even, f of x and f of negative x give me the same number. If it's odd, f of x and f of an x don't give me the same number, but they give me what numbers? Numbers that are what of each other? Opposite of each other. You know, so for example, if this is 3, this one is going to be negative 3 on an odd function. Okay, if this is 3, this is going to also be 3 on an even function. So the y values are the same on both sides with an even function. They're opposite with an odd function. So let's take a look at a graph of something. F of x equal x cubed. What is 0 cubed? 0. What is negative 1 cubed? Negative 1. What is 1 cubed? 1. Negative 2 cubed? Negative 8. And 2 cubed is 8. So if I graph these points, 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8 is right here. And so what this looks like is this even or odd? This is an odd function because what it's doing on one side of the axis, it's doing the opposite. And what I see here, f of negative 1 and f of 1, they are not equal, but they are what to each other? F of negative 1 and 1 are not equal, they are what? They're opposites, okay? F of 2 and negative 2 are not equal to both the same number, but they're opposite numbers from each other. That's what makes this an odd function. So yes, this is an odd function. Okay. Let's go back where we started the lesson real quick. Those graphs, when we were saying even and not even, now we know what an odd function is. So what about this? What kind of function is this one? Yeah, this is an odd function, okay? Because what I see is it does the opposite thing on both sides of the action. What about this one? This is an odd function, does the opposite thing. Now what about this one? It's neither, okay? So this is neither, this function is neither even nor odd. So it's possible that a function can be even, odd, or none of the above, okay? And then we know that this function is even. So if it's exactly symmetrical about the y-axis, it's even. If it's exactly opposite on both sides, it's odd. Anything else in between, it's neither even nor odd. You guys take a look at the, I think we can work this. Let's take a look at a couple examples here. What is this function you see graphed, even or odd? Even, okay. If the point 2, 0 is on the graph, what other point do you know has to be there on an even function? Negative 2, 0, okay. If it's an even function and it has 2, 0, it's also going to have negative 2, 0. If the point 1, 1.8 is there, what other point has to be there on an even function? Negative 1, 1.8, okay? I have to be able to get the same y value on both sides of that axis, okay? Let's look at the next question where I have an odd function. So you can see in red, this is an odd function, okay? If the point 1, 0 is on this graph, so you see 1, 0 right there, what else has to be there? Yeah, negative 1. And with odd, I get the opposite. So negative 1, but what's the opposite of 0? Positive 0, negative 0, all turns out to be what? 0, so it doesn't matter. But if the point 0.42, negative 3 is there, if it's an odd function, what other point has to be there? Negative 0.42 and what? Positive 3.0, okay? If it's even, I'm expecting to get the same y values. If it's odd, I'm expecting these y values to be the opposites of each other. Does everyone see where that's coming from? Okay? So, what we're finding out, if I've got a graph and I've got xy on this graph, okay? And I know that f of x is my y value, okay? If the function is even, f of negative x is going to be equal to what? Yeah, it's going to be my y or f of x, okay? Same thing. If it's an odd function, f of negative x is going to give me what? Negative y, or negative f of x. When we meet tomorrow, we'll be spending more time with this algebraic definition. All this means is you've got a function f of x. If it's even, f of x and f of negative x are the same thing. If it's odd, f of x and f of negative x, they aren't the same thing. They are opposites of each other, okay? So whatever positive value one gets, the other one gets the exact opposite negative value. So just to drill this home, this is the kind of question you would also see on a quiz or test. If this point is on a graph, okay, what has to be there if it's an even function? What other point? Negative 1, 6, okay? If it's odd, what point has to be there? Yeah, negative 1, negative 6, okay? If negative 1, negative 6 is on the graph, what has to be there if it's even? 1, negative 6. And if it's odd, what has to be there? 1, 6, okay? So what you see here is I'm looking at the x value. I'm changing the x value to the opposite side of the axis. If it's even, the y values match every time. If it's odd, the y values are opposite. So in this case, if the function is even, what else has to be here? Negative 3. If it's even, negative 3, negative 4. What that means is if your x values change, your y values stay the same if it's even. If it's odd, what has to be there? Negative 3, 4. Okay. And in this case, if I got a and b, if it's an even function and a and b is on the graph, what has to be there if it's even? Negative a and what? Negative b. If it's odd, what has to be there? Yeah, negative a, positive b. So what you're seeing is on even functions, these y values are the same as these y values. On odd functions, the y values are opposites of each other. So if pi square root of 3 is on the graph, what is there if it's even? Yeah, negative pi. Yep. And if it's odd, what is there? Yeah, negative square root of 3. Okay. So that's just drilling home the fact that if you know if it's even or odd, and I give you a point on the graph, what other point has to be there? Okay. You guys take a look at a couple examples here. So these negative 3, 2, I'll just put the answers here and you can see if you're getting that right, but I think you can handle it at this point. So as you're working through that, you should get not similar, but the same answers to what I have up here. Okay, so just to bring it home, sort of a short lesson today. You should be able to look at a graph and tell if it's even or odd. How do you do that? When you visually inspect a graph, what tells you it's even? Yeah, a mirror image because it's reflected about which axis? The y-axis. How can you look at a graph and tell if it's odd? Yeah, on both sides of the y-axis, you look at it, it's doing the exact opposite thing, okay? If I give you points on a graph, you should be able to give me the corresponding points that make it even or the corresponding points that make it odd. And you know, even functions are symmetric about the y-axis. I think of even means the same. Even, same. Odd means opposite. And odd functions are symmetric about what? Even functions are symmetric about the y-axis. Odd functions are symmetrical about what? Not the x-axis. It looks opposite when I look at it, but it's symmetric about what? The origin. Okay? So it's symmetric about a point. So what it does on one side of the origin is doing something symmetrical on the other side. Okay, so you should have time now pretty much to get through the homework assignment for